Multiplying polynomial expressions is the name of the game here in 4.3, and it does require some introduction here. I just want to show you a simple example of something you've seen before. This single-termed expression of 5 called a monomial multiplied with this two-termed expression called a binomial. You recall the distributive property that says if you multiply something like this with a two-term guy, you could use the distributive property. Let me just kind of back up before then and to say this. If I take something like 5 times 2, this is the shorthand version of repeated addition that's happening here, and we can think of this as 5 of those guys added together having the same value, right? So that's going to be 10. And so this here, again, could be thought of as 5 of those added together. Well, if I do that, I could take 5 of those and add it together and get to my multiplied version. So here's what that looks like. 5 of these guys added together. So 4x minus 3's. So I took the time to write that out here for your enjoyment. So 1, 2, 3, 4, 5 added together. Now, when you saw something like this previously, we could combine like terms here, the x terms. And I just want to show you something. I want to rearrange the x terms and the minus 3 terms here in order so that you know that, let's see, there's 1, 2, 3, 4, 5, 4x's. That's 5 times that. And then 5 minus 3. So that's 5 of those, or 5 times minus 3. So if you simplify that, I'll show you why I wrote that in a minute, but 5 4x's is 20x. 5 minus 3's is a negative or minus 15. So again, the distributive property says you could have done it this way. 4 of those is really 4 times that. I'm sorry, 5 of those is 5 times that. 5 of those is 5 times 3, and so you get 20x's multiplied subtracting 15. But what happens if we think of not 5 4x minus 3's, but let's think of two additional 4x minus 3, something like this. So 2 additional, meaning not 5 but 7, and maybe we should do this to indicate two additional more. So not just 5 again, but 2 more, and so we'd have to tack on 2 more of 4x minus 3's into this. So it looked like this. So there's 7 of them. You may take the time to figure that out. 1, 2, 3, 4, 5, 6, 7 of them. And if we rearrange them, you'll get what? 7 4x's, meaning the first 5 and then 2 additional. And then you'll get 5 minus 3's and then 2 more. So 7 minus 3's there is how that arranged in order. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that combines to 28x. And that combines to minus 21. So now the question is, I want to walk you through this, is what happens if you have this term, and can we use the distributive property to kind of bypass all of this? So let's take it one by one. I mean, if we don't have that plus 2, that's just 5 times this term here. And so what we would get here is 5 times 4x minus 5 times 3. So that's the 5 distributed with both of those. And the pattern that I want you to see here is that we need 2 more of those and then 2 more of those to get our right answer here. So we'd also have 2 more of 4x's, and we can think of that as adding 2 times 4x. And we'd also need 2 more minus 3, so we can think of that as adding 2 times a negative 3. Or 2 more subtractions of 3. Maybe we should say that way. That might be better. So 2 more subtractions of 3 would be written that way. So now look at, so we got 20x minus 15, just performing the multiplyings in there, added to 8x and subtract 6. So now look, that's 20x plus 8x, there's my 28x, minus 15 and a minus 6, there's my minus 21. Was that shorter than this? Absolutely. And here's the idea. When you have two binomials multiplied together like this, it really is this guy distributing with each piece of that subtraction, and then that guy distributing with each piece of that subtraction. And it doesn't matter if that's addition or subtraction, but it's each of these distributed with each of these. That's going to give you the right answer. So that's what I want to show you here, a couple more examples of.